Alright, we're in section 1.5 and we're going to do exercises 1 to 4. I have the exercises here, and you'll notice there's two parts. We're going to do all of these, so all the parts, A and B. And it says, use the law of exponents to rewrite and simplify the expression. So this won't be too hard. 1a. 1a says 4 to the negative 3 over 2 to the negative 8. Alright, so remember, when you have a negative number as your exponent, you just flip the entire term. So if it's in the numerator, put it to the denominator. If it's in the denominator, put it up into the numerator. So this is the same as 2 to the 8, and of course change the sign of your exponent from negative to positive. So this is 2 over 8, 2 to the 8 over 4 to the 3. 2 to the 8 is 256 if you plug that into your calculator, and 4 cubed is 64. If you plug that into your calculator, 256 over 64 simplifies to 4. So that's the answer for 1a. 1b says 1 over the cubed root of x to the 4. Now, there's only so far we can go with the simplifying of this thing and the rewriting, so I'm just going to rewrite it to what I feel is the correct answer. So don't forget also, when you have a numbered root of a term, that's in exponential form, that's just 1 over whatever number root. So this is the same as x to the 4th of 1 over 3. And that simplifies to just x to the 4/3. So I'm guessing that's all they want. That's our answer. Alright, 2a. 2a. 8 to the 4/3. This you can break up the exponent into 8 to the 4 times 1/3, or you could think of it like that. So the 1/3, remember, transforms into a cube root, because a fraction as an exponent is just a radical, with the denominator of the fraction being the number of the radical, whatever you want to call that. So when we evaluate 8 to the 4, I put it in my calculator, and 8 to the 4th power is 4096. And then I plugged in 4096 and I took the cubed root of that just to see if it was a perfect cube, and it is. So the cube root of 4096 is 16, which is our answer. Alright, 2b, or not 2b, just kidding, this isn't English. 2b, so this one says x times 3x squared cubed. Alright, you have two terms technically in this parentheses right here. You have a 3 and an x squared. So you can distribute this exponent, and this is the same as x times 3 cubed, 2 times 3, which is just x times 9, x to the 6. So this is a 1 here, and when you're multiplying terms with the same base, you're just adding their exponents. So we're multiplying terms with the same base. We have the base of x, a base of x. So this simplifies to 9x to the 7. And that is 2b. Okay, let's move on to 3a. 3a is b to the 8 times 2b to the 4. I don't know if y'all can see that. Let me rewrite. So that's, okay, 3a is b to the 8 times 2b to the 4. Remember, we can distribute an exponent to, I don't want to, we can distribute it within one term, but you can't distribute it if you have subtraction and addition of terms. So 2 to the 4 is 2 times 2 times 2 times 2, so that's 4 times 4, which is 16, b to the 8. We're multiplying same bases, so we're just adding, so this is 16b to the 16. It's kind of confusing. Alright, 3b. 3b says 6y cubed to the 4 over 2y to the 5. Okay, so distribute this exponent. So 6 to the 4, I'm just going to put in my calculator is, oh my word, 1296. Multiply. When you have an exponent to an exponent, you're multiplying the exponents. So y to the 12. This stays. Okay. So you can divide your coefficients. 1296 divided by 2 is 648. And you have the same bases being divided here, so you're just subtracting their exponents. So 12 minus 5. 12 minus 5 is 7. So that's as far as we can go. Okay, so we have same bases being multiplied here, which means you're just adding their exponents. So this simplifies to x, so you're adding 2n to 3n plus, or 3n minus 1. So you can only simplify, or you can only combine the n terms. So this simplifies to 5n minus 1, x to the n plus 2. So if we, let me see, this simplifies to x to the 5n, just adding to the negative 1, x to the n, x squared. This comes down and you add it. So this is, it's really bad, x to the 5n over x to the n. So this comes down, right? And the sign changes to positive 1. So we still have x squared here, and then we have 1 here. So you're adding the exponents because it's the same base. So 1 plus 2 is 3. And then you're subtracting your n's up here. So this ends up being 4n up here to x to the 3. Alrighty, and if you want to get it in just 1x, this can come back up here, making it x to the 4n times x to the negative 3. And you're just adding those, so the final answer would be 4n minus 3. That was a doozy. I had to think about that one a little. B. Oh my, square roots. Okay, this is 4b. So 4b says square root of a times square root of b, well, square root a square root b over cubed root ab. I'm sorry if this video is too long. Just doing the problems. Okay. So let's rewrite this whole thing. Is just, I can rewrite it. I can write it like that, yeah. And then AB to the 1/3. So I'm going to distribute the exponent here, and we can do that because they're being multiplied, not added or subtracted. That's illegal. You will be arrested. So this is just a to the 1/2 times b. Okay, so multiplying fractions. Numerator times numerator, denominator times denominator. So it's 1/4. Distribute here. We can do it because it's multiplication. A to the 1/3, b to the 1/3. We could bring the terms of the denominator up by rewriting their exponents as negative. So ultimately we have negative 1/3. So 1/2 minus 1/3, oh, we're arithmetic with fractions. I'm going to do it in orange. So 1/2 minus 1/3, get like denominators. Oh, I'm sorry. Get like denominators. So multiply 1/2 by 3, multiply 1/3 by 2. So 3 minus 2 is 1/6. And then 1/4 minus 1/3. Multiply 1/4 by 3, you get 3/12. Multiply 1/3 by 4, you get 4/12. So 3 minus 4 is negative 1/12. Wow, so you end up with, let me go back to magenta. So actually, let me do it in this becomes a to the 1/6 and this becomes b to the negative, I'm sorry, I brought it down because it's negative. So when you move it, when you flip it, the exponent changes. And this can be simplified even further. Let me go back to the original magenta. As the 6th root of a over the 12th root of b, if your teacher or professor or whoever wants it as worked as possible, you can do that.